This is our today lecture, and the objective or the applications are written over here. Actually, we were discussing the adsorption without dissociation by using the Langmuir adsorption isotherm. And in the previous lecture, we have derived an equation used for the Langmuir adsorption isotherm, and these are the now the two objectives for the today class. Actually, we discuss only case one, adsorption without dissociation. And these are the two forms, two modification form of the Langmuir adsorption isotherm in case one, and which is the adsorption without dissociation. And these are very important because now we actually we want to apply on our experiment. And this I think I have also discussed in the previous lecture, but surely I will be describing here again. And then we will move to the second modified form of the Langmuir adsorption isotherm. And in two cases, as you are visualizing over here, this case is for the when adsorbate is the liquid and adsorbent is the solid. And in case if adsorbate is the gas and adsorbent would be again the solid. And then how can we use this adsorption isotherm according to our data or our experiment, depending on the applications in which we are going to apply. So application is important. Actually, that is the objective or the output of what we are going to theoretically study in these lectures. So moving to the first one, and here this is the yes. So first is the by considering the case liquid and the solid. As I said, I have explained already, and this is the equation for the Langmuir adsorption isotherm. And in case of, because we are now using the liquid, and in liquid it is easier or better to show the concentration with moles per liter. That's why C is written over here. And in case of the gas, it should be a pressure. And here theta is, as already explained, it is the fraction between these two. And this is M is the substantial amount of adsorbate, adsorbed per gram of the adsorbent. And A max is the maximum amount of the substance of the same. Uh, what is over here, it is the adsorbate. K is the adsorption constant, or we call the equilibrium constant, and C is the concentration of the adsorbate. So moving to the next, I'm just replacing the theta in this equation, and this equation becomes like this. And further rearranging the equation, multiply A max to right hand side, and this equation becomes like this. And on taking reciprocal of this equation, that means dividing one by the whole equation, and this will be 1 over this, and this is going to reverse, because dividing 1, it will be the reverse of this form. And after just opening this whole equation, 1 over A max and 1 divided by this, and Kc divided by this whole, and this equation becomes like this. And now you can further modify this one, because Kc is going to cancel out Kc, and this is remain 1 over A max, and this is the same over here. And this we have discussed in the previous lecture. This is the equation, uh, straight line with intercept, and here 1 over A max K is the slope, and C is the x-axis, and this is the 1 over A max is the intercept. And then if you plot just M over versus C, then you may get a curve or the isotherm showing the maximum amount of A max starting with the M 0. And then if you plot this straight line equation, and then this will give you the straight line, because now you are going to plot 1 over M on the y-axis and 1 over C on the x-axis. and this slope is the positive. And when you get the slope and the intercept from the graph, and this is actually the intercept will be equal to 1 over mx as indicated over here. So from here to here, you just put the value and you can get the value of the Amax, and Amax would be equal to 1 over intercept. You simply divide in this intercept by 1, and that will give you the Amax. And here slope is the dy over dx, and that is b over a, and this slope is written over here. This is 1 over k a max. So you can get the value from the intercept, put the value over here, and that would be a easier way to get the value of the equilibrium constant or the adsorption constant for the Langmuir adsorption isotherm. So actually this equation we will be using in our experiment as well, because this is a generalized form to apply when we are using adsorbate as a liquid and the solid is the adsorbent. So this is one form of the Langmuir adsorption isotherm. We have actually modified this according to our need and coming to the straight line equation. That's why this is called the modified form of the Langmuir adsorption isotherm. So moving to the second one, and this is also very important, modify form when your adsorbate is the gas, and then we have a look how we are going to modify by, because in case of the gas, pressure and volume are important because you are using the adsorbate as a gas. So actually in the same way, we are going to modify this equation as per our requirement. Actually, I'm moving, modifying with the pressure and the volume by certain modification. So just have a look what I'm going to do with this equation. It is just the rearrangement. Now this is our denominator. It is going to multiply with the theta, and this would be the just rearrangement of this equation. And this I have already explained over here. So again, this theta is the fraction of the total surface covered by the adsorbed molecules, or you can say that this theta is the number of the adsorption sites occupied and number of adsorption sites available. So how, if 100 are available and the 20 are occupied, so this is the ratio between 20 and 100. And as said before, this maximum value of this theta will remain 1, because if all surfaces are occupied, then 100 divided by 100, it will be 1. And these are the different, actually, now we are going to use this fraction with by using volume over volume infinity or volume max, because in case of the gas, volume and pressure are the important. So here V actually the volume of the gas, P is the pressure of the gas or the adsorbate, K is the adsorption or the equilibrium constant, and this V infinity or the V max would be the maximum volume of the adsorbate correspond to the complete monolayer coverage. So this is you can get from the isotherm as well, but we are going to calculate by using the modified form of the Langmuir adsorption isotherm. So now putting the value of theta is here. I'm just replacing this theta with the maybe the this or maybe the this. You can use any of the fraction. So when I put the theta in this equation becomes like this. So V over, just I'm putting the replacing the V divided by V infinity. The rest of the equation will remain the same. Now by rearranging, now I'm going to multiply because it is going to divide over here, and if you move to the right hand side, this is going to multiply with the Kp, and the equation becomes like this. And again, by taking the reciprocal, actually what is the purpose or objective of doing all these three? I am modifying, this is the modified form of the Langmuir adsorption term, but I am going to have a straight line equation, because this is very important, and you can easily verify the any adsorption isotherm by using the straight line equation. So main objective of this modified form is to convert this non-straight line equation to the straight line equation. Otherwise, I'm just now rearranging the equation to moving to the straight line equation. So in a similar way in which in the previous slide I have shown to you. So by taking the reciprocal divide one by this and one by this, and this equation become like this. And then further you can multiply by the pressure on the both side. When you multiply the any of the parameter on the both side, then there is no change in the equation as well. So when you multiply, so multiply this equation p multiply by 1, this will be p, and this will also be a p. After this one, know what is the difference over here. Now you can cancel out p is here in the numerator and the denominator, so you can cancel out, and this will become 1 over k v infinity. This will remain the same. And in the second form, you are going to actually rearranging this equation again. So it is dividing over here, and if you are moving to the right hand side, it will be multiply with this factor, and this will be the modified form of this equation. And again, this is the our previous equation we have derived in the previous slide. Again, I'm going to just this is the same thing, just I'm going to multiply with the 1 plus kp. So just this equation will become like this. There is no difference between this equation and this equation. And now I am again opening this equation, 1 divided by this and kp divided by this whole factor. So 1 divided by kv infinity and kp divided by kv infinity, just opening this one with the in this way. And then in the next form, this k is going to be cancelled out because multiply divide is cancelled out, and this is the another form of this equation. And by moving to the next phase, just I am rearranging by moving this to this side, and this I am taking here over here. Why I am going to do, because I am just modifying or I'm going to show you this is the straight line equation with the y equal to mx plus c we're having with intercept. And this k is the adsorption constant or the equilibrium constant, and this is the maximum capacity. As we have discussed before, these two will remain the same. If it is, let's suppose 100 sites are available, also there will be the 100 occupancy, and this maximum value will remain the constant. So all these two are the constant, and one constant, there is no variable along this. That's why this is called the intercept. And here p is the pressure, and this is variable, and this again is the constant, and the constant is 1 over v infinity is the slope, and this p will be the x-axis, and this is the variable. So you know, you can easily understand this equation we can use to get the straight line. If we fit the data and it is giving you the straight line with the intercept, then you can say that this is the verification of the Langmuir adsorption isotherm. So verification is simply is the fitting of the data by using this equation. If you fit the data by this equation, then this is the you are going to verify the Langmuir adsorption isotherm with this modified form. So again, this is the intercept as I have explained, and this is the slope dy over dx, and this will remain 1 over v infinity. P is the x and p over v is the y. So when you plot between p over v, actually here the units are given. It is a kilopascal and the volume in centimeter cube, and the pressure is again kilopascal. So actually this is the p over v. I am going to plot on the y-axis, and this pressure on the x-axis. And when you get you will get the straight line with the intercept, and from 0 to here, let's suppose this is 1 point, maybe the 2 1, and this is the intercept, and by with the slope you can get the slope by plotting the y-axis and the x-axis. So the ratio between dy over dx will give you the value of 1 over v infinity. So this is the again the second modified form of the Langmuir adsorption isotherm when your adsorbate is the gas. So I explaining one of the example, and I will give you another example to do at home. So let's suppose this is the data, and the data is given over here. It is for the Langmuir adsorption system. As it is already said, this data will fit the adsorption Langmuir adsorption system, and this would be the verification of the Langmuir adsorption system. And the rest, the volume and the pressures are given over here. So the pressure is given over here and the volume is here, as you need this only this data to verify the Langmuir adsorption system and to calculate the V infinity and the adsorption constant or the equilibrium constant. So of course you will be using the same equation as we have derived in the modified form, and with the plot of the data you will get the intercept and the slope, and from the slope and intercept you can calculate the value of V infinity and the value of the adsorption constant. So here is the solution by using this one. The first, because you have to plot P, the pressure, and the P over V. So this will remain the same. And here actually you will use the volume, divide each volume with the pressure. And so P divided by V, you will get these value. And then when you plot the P over V versus P, this is your y-axis and this is your x-axis, and you can plot manually, or you can use the Excel to plot this one graph. And after the plot you will get these points, and this is the equation is written over here. So actually this graph with the equation, or maybe the manually you can use, with the slope is 0.009 and the intercept is 1.2, as it is clearly indicated over here, near to 1.21, maybe the 1.2, as you can mention, as you can get the value from the graph or from the Excel. So this is the slope, and you can get the slope. You just 1 divided by this will give you the value of 111 centimeter cube, and this is the maximum occupancy of the volume of the gas you are using for this exercise. And your intercept is here, and with the intercept, because here intercept is 1 over k v infinity, so k will be 1 over your this v infinity and your intercept, and this is the, you have already calculated the v infinity from the slope, and you just dividing the value of the slope you are taking from here, and this is 1.2. So 1 divided by 1.2, and this you can calculate, and this will give you the value of 7.51 exponent minus 3 kilo per Pascal. And these values are very, very important, because when in the next lecture we will discuss some of the applications. Actually, these values are going to decide whether your adsorbent is perfect or not, how much it is active to for the application or for the adsorption of the adsorbate. And these are the value which give you the indication how you are going to apply a specific adsorbent for the, let's suppose, for the degradation of the textile, or you want to remove the pollutant contaminant out of the water. And so this value will giving you the better idea which adsorbent is more appropriate for the degradation or the removal of the pollutants out of the water. So in a similar way, this is your the exercise you can do at home. In a similar way, you repeat again, the pressure and the volume are given, and you have to first calculate P over V, and the P will remain the same, and then you should plot and get the value from the slope and intercept to have the value of the K constant and the V infinity. And the values are written over here, and you should plot manually and by using the Excel, and then you can compare with the actual answer which are given over here. So this is all about our